Here we're using a differential pressure transmitter to measure the amount of water inside this white tank. The white tank is holding water as indicated by the sight glass over here, but we're also measuring the water level electronically with what is known as a dip tube. There's a small metal tube that goes into the top of the tank and dips down into the tank. As water level builds up, the air that is passed through that tube has a more difficult time bubbling out the end. And as water level builds up, the back pressure inside that dip tube increases proportional to the water level. The air flowing into the system through that dip tube is measured by the small rotometer and indicated by a very small ball at the bottom. The transmitter is measuring the back pressure within that tube. You'll notice the airflow coming into the system goes through a T, it goes to the dip tube up here, and in that T connection is where our differential pressure transmitter connects. We're not really using this as a differential instrument so much as we are as a gauge instrument. This tube right here goes to the high side port of the differential pressure transmitter. The low side port is simply vented to atmosphere, as you can see right there. So it is measuring the difference of pressure between the dip tube and atmosphere. So essentially it's measuring the gauge pressure within that dip tube. This is a linear system. The higher the water, the more air pressure, the more signal coming out of the transmitter.